In object-oriented programming, we define classes, a blueprint, like a description of an object, and then when the program is run, instances of that object are created. These instances can have differences between each other of those properties. Like we can have a bunch of different transform components in Unity, and they all have a vector3 position property, but all their properties are different. They're in different locations. But what about things that we don't need multiple instances of, or things that should be universal for all of the classes? And that's where static properties, or static classes, static methods, that's where static things come in. We can create a class and define it as a static class. And that means there's no instances of that class that can be made. Or you might better think of it as there's only one universal instance of that class being made. To define a class as static, we just type the word static before the definition of the class. So that's pretty neat, but things get really interesting when regular C# classes that are not static start having some static properties or some static methods. A brief aside, in C# we use the word function and the word method pretty interchangeably. There are differences that depend on like what programming language you learned first or who taught you programming and how we use those two words. But in C#, their differences between them kind of don't matter. So the way we talk about them is pretty interchangeable. You'll see me often use the word method for static things and function for not static things, but that's ridiculous and untrue. But it's just a bad habit I picked up. Don't worry about it. When you hear method, just think function. Cool. So any variable that we mark as static will only have one version of it, one little slot in memory, accessible by anything that has the rights to change that variable. But it'll change it for every instance of the class, because there's only one. It's like a global variable, just sort of. I'm hesitant to use the word global because that's a thing in some other languages, but kind of. Static properties in Unity cannot be serialized. That means we can't change them in the inspector. In Unity, we tend to use static properties for not too often for regular components, but we use them for things like game managers, event systems, and higher level bits of code that need to be used in a wide variety of locations, or need to be connected to a wide variety of things. I very often write a static utilities class with some common math functions that I might use all over the place. The input class is another example of a static class. We can just type the type input instead of a specific variable. We just type the type name, and then we have all of its static variables and static functions, like get button down, and we can use that wherever we want. That's a really good example and a nice place to use a static class. There's only one input manager, or there should be, and we can deal with it from there. Many structs contain static properties as well. One of the biggest examples of them that you've already seen and used many times is a shortcut to common instances of the struct that one might need, like vector3.up or vector3.write. That's a shorthand for writing new vector3 010 for vector3.up. Quaternion Identity is another static property, and it's just a version of a quaternion that is convenient to have access to wherever we want it. Let's see a specific example of a static class in action, like a global settings manager for some player settings. I'm going to create a static global player settings class. And a static float property to hold my volume variable. That's all I'm going to need in this class for this example. Here in my menu user interface, I have a volume slider. I'll write a little bit of code that will access this volume slider, and whenever the slider's property is changed, it'll change the global player settings volume variable. That's all the menu UI needs to do. Now let me go find where some audio is being played. That audio player doesn't know anything about the volume slider. In fact, the volume slider user interface and these objects might not even exist in the scene, but my volume data isn't being stored where those user interface objects are being stored. The data is being stored in this separate static class, and I can easily access this anywhere in my project. So here I'll have a reference to it just by typing global player settings.volume, and I'll set my player volume to that right before I play the sound. Right now, static properties probably seem really convenient and amazing. That's definitely the reaction you had. But there are a lot of important considerations to make, and a lot of downsides to know about them. Like I mentioned before, static properties can't be serialized by the Unity editor. We can't change them in the inspector. We'd have to create some object to assign a value to it on start, and maybe we accidentally have two of these objects in the scene. Now we don't know which one is assigning the value after the other one, which value it's going to be, and we can get bugs. That's a pretty arbitrary example, but that exact situation where multiple things are changing a value at roughly the same time, creating what we call a race condition, where we don't know what order they happen in, or they're happening in the wrong order. That's a really common error to get when working with static properties in Unity. In our volume example, we didn't have to worry about that too much because there was a really clear chain of command. The volume user interface object would change the slider property, and nothing else would change the slider property. It was very rare or unlikely that we would have multiple things changing that value at the same time. The only other thing that would change that value would be something that was loading the settings from the, when we save the player settings. In a more complex example, keeping track of that chain of command, so to speak, can get kind of hairy. Another downside is that static functions can be really annoying to write. When you create a static function, you can't use any instances of other objects inside of it. Or at least you can't without first passing those instances into it as a property. The only data you can use in the static function are other static properties, static classes or variables, or things that you've passed into it directly. It's very self-contained. And that can be annoying to write and very easy to overlook because we can define static functions and non-static functions right next to each other in our code, and they don't behave the same and they don't have access to the same data, which can easily trip us up. Static objects are very powerful, but we have to be careful not to use them when we don't need to, especially in Unity development where there's a lot of complicated systems that we don't have total control over. Some of the downsides to static properties will become more clear as we get into singletons and some other patterns. But for now, we need to make sure we understand them, use them where appropriate, and take full advantage of the convenience that static properties can offer.